Welcome to today's session on how to extend your Cloud Run containers capabilities using Sidecars. I am Sagar Randive. I'm a product manager on Google Cloud working on serverless.
And I'm Clayton Coleman, longtime Kubernetes contributor, and I'm the team lead for workloads on GK, and I work with Cloud Run to make sure we have a consistent platform for all of your containerized workloads.
Before we dive into the topic of Sidecars, let's talk a little bit about what is Cloud Run. So Cloud Run is Google Cloud's fully managed platform for running your containerized applications in a fully serverless manner. Cloud Run allows you to deploy and scale applications fast and securely in a fully managed environment. It's simple and automated. You just need to bring your container, and we do the rest, including scaling down to 0. There is no infrastructure to manage, which means there is no compute cluster management required or network connectivity management required. And it allows you to go faster. A developer is able to deploy a Cloud Run application in a matter of seconds. So what are the use cases of Cloud Run? Hosting public websites, APIs, where users can render server-side pages, REST or GraphQL APIs, bidirectional streaming with WebSockets, or hosting private services, internal-only services that can talk over private network with each other, which may include websites, APIs, or HTTP or gRPC-based microservices. And lastly, running data processing pipelines, which include processing queues, messages, for example, pub/sub messages, processing data for event-driven architecture, scheduled scripts, as well as background and batch data processing. So there are two types of Cloud Run resources: services and jobs. A Cloud Run service follows purely a request-driven scaling. Instances within a revision are scaled behind Google Managed Load Balancer. It provides out-of-the-box URLs and TLS termination. The built-in traffic splitting and gradual rollouts let you reliably create new revisions and lets you manage your revisions without any disruptions to SLOs. A Cloud Run service has multiple trigger points. The trigger sources like HTTP2, gRPC, events, and sockets. And a Cloud Run service provides multiple pricing options like pay-as-you-go pricing, pay-per-request pricing, or paying for the lifetime of an instance. Then you have Cloud Run jobs. Cloud Run jobs are nothing but a set of containers that run to completion. They are not triggered by any HTTP requests. Cloud Run jobs are executed manually or on an automated schedule. And you only pay while the Cloud Run job is being executed. You do not pay outside the Cloud Run job execution time. Cloud Run is available today in all 38 regions and 115 zones, including over 200 plus countries and territories. Today, I'm excited to announce that Cloud Run supports Sidecars. So what are Cloud Run Sidecars? Previously, every instance in a Cloud Run service ran only one container. We are introducing Cloud Run Sidecars, allowing you to start independent containers that can run alongside your main serving container. You can use Sidecars to monitor your applications in real time, run client connection proxies to connect to Cloud SQL or AlloyDB databases, securing your application networking by running proxies like Envoy or Nginx alongside your serving container, and much more. And to dive deeper into these use cases, I'll pass over to Clayton. Over to you, Clayton.
Thanks. And there's a number of features in sidecar containers that we think are important. So first, it's not just one sidecar, it's up to 10. We think that sharing in-memory volumes between multiple containers allows sidecars and their primary application to work together for more efficiency, generally. Configuring Kubernetes-style health checks for individual containers so that the containers can independently fail and then be restarted. Specifying the startup ordering of containers if some containers have dependencies on another, and we'll talk about that in a minute. And finally, if you're starting up in a certain order, you often need to have a consistent order when shutting down. So sidecars in general, you're complementing the main container with a supporting workload that aids in ensuring consistency. Sometimes that may be between different teams, between different programming languages or frameworks, where you want to ensure a consistent behavior across them. And sometimes it's a more complex use case that just wouldn't be possible if all of the code was in a single application. Many of these will be familiar to Kubernetes users in the audience, which already allows multiple containers to run side by side as part of the same application. While developing Cloud Run sidecars, we looked at existing container production use cases in addition to taking direct feedback from serverless container users. This breadth really gave us the confidence that we could simplify and streamline these scenarios, which is part of the promise of Cloud Run, as well as add some new features, which we'll talk about how those might come to Kubernetes in the future. A classic sidecar use case is adding a second container to observe the first. You might deploy an OpenTelemetry sidecar to write metrics to the managed service for Prometheus and get the same metric across all of your runtimes in cloud monitoring. It might also act as a temporary relay to help you migrate from one monitoring service to another. For instance, if you've decided to switch from managing your own Prometheus to using managed service for Prometheus. Some users might also use a monitoring sidecar to perform local analysis of logs. That could look for unusual behavior in the first container without necessarily shipping every line to log service, which might save you cost or increase the performance of the container itself. The sidecar allows a clean separation between the application code and a common or temporary problem managed potentially by the same team or by another team. Adapting existing workloads to run in Cloud Run is a second use case that we think about. A lot of existing workloads grew up in a period where they had significant existing proxy infrastructure to support the application. That might have been, in the early days, that would have been Apache, which dates me when I say that. But these days it might be Nginx or even Envoy, where you're performing a significant amount of logic before the request actually hits your custom application. You might also have a need for a capability that's typically provided by one of these proxies, like local HTTP caching for expensive requests. In this case, a sidecar acting as a front proxy would allow you to integrate those existing proxies and then potentially provide more complex logic on the way as requests pass through to your main application. And that could be permanent, or that could be temporary. In either way, the sidecar is letting you complement an existing app with functionality that, in this case, proxies already do. And it doesn't require you to duplicate that in a particular programming language. So if you wanted to have consistent cache behavior across 3 or 4 different microservice languages, because your teams are relatively diverse, you can ensure that through the sidecar. Going even further into networking use cases, a more advanced use case that we're starting to see is the use of a microservice as a proxy for other services. And in this scenario, the Envoy proxy can handle incoming requests, and we've got a supporting application alongside. And that supporting application actually is doing analysis or processing traffic as a filter or as a detecting proxy. And then after a determination is made by the main application, whether this request is malicious or not, it passes that on to a remote service. And I mentioned Envoy. Envoy has a lot of advanced networking capabilities. The pattern could also be used to bring your own service mesh to Cloud Run, or to use this as a serverless gateway to bridge between a set of applications outside of Kubernetes and some on Kubernetes. A lot of the cases before have been talking about incoming traffic. Another sidecar use case that we think is a big opportunity to really accelerate, while still keeping the serverless properties of Cloud Run, is to simplify connectivity to the dependencies of our application. Here we're using a database client proxy to authenticate and pool connections in a sidecar, and that reduces load on our backend database. The application also can be oblivious to where the database actually lives. As a nice benefit, your local test environment can use a local connection to a local database for testing. When you deploy into production for Cloud Run, the same connection string is in place. So you don't have to change config between the two environments, which is a nice little benefit. It's an opportunity to enforce secure connections from your front ends to your databases, and to use more advanced features like IAM-based authentication. We currently offer open source proxies for Cloud SQL and Alloy DB that you can configure to your needs as a sidecar. And this use case is also an example of where startup and shutdown ordering becomes important. We don't want our main application to start before the proxy has. Because if it does, we might have to add significant retry logic that might add error messages to the logs. It might add failures to the events. By adding startup and shutdown ordering, you can eliminate a source of operational friction that you're using this proxy that gives you accelerated performance without the main application having to be aware of it, which is one of the key goals of sidecars. And finally, most of these examples have involved a single sidecar container. We wanted to cover one that had two. This is a more advanced usage pattern, and it's similar to some of the previous ones. So in this case, you might have Envoy acting as a front proxy before requests hit the application. But instead of the application being the one that's providing that filtering logic, we want to standardize how policy and access checks are handled across a large set of microservices. And so here, we're showing an example of using an open policy agent sidecar, which will make policy-based decisions on behalf of the application. These two sidecars working together get the best of Envoy, the best of Open Policy Agent in providing a standard way to represent request policy, and the application itself remains agnostic. And this, you can think about this as separating the responsibility between teams as well. The application team might want to specify the policies for themselves using the Open Policy Agent language. And the team that might provide this consistent behavior wants to ensure that all the applications perform well, that if they find a bug in the integration between the two, they can roll that out to all of their microservices at the same time. And so sidecars also help bring teams together. And we've added 2 sidecars here. Since we support up to 10, there's no reason you have to stop here. You can imagine, if you so choose, combining some of the previous patterns. You might have a container to forward metrics, 2 to apply policy to requests, and a 4th as a client proxy as a database. I'm not saying that's a good idea, but it is something that we support. And as I mentioned earlier, many of these patterns are in common use in Kubernetes. And we increasingly hear from customers using Cloud Run and GKE together. Cloud Run Sidecars expands the set of workloads that can run on both Cloud Run and GKE. And you can see from the example configuration how Cloud Run requires only superficial changes to adapt this multi-container Kubernetes deployment to a serverless Cloud Run service with sidecars. We often talk about how Cloud Run simplifies Kubernetes. Sidecars are also an example, hopefully the first of many, where Cloud Run helped influence the community. Key feedback from Cloud Run use cases and customers about Sidecar helped us guide and accelerate a Kubernetes enhancement proposal for sidecars that resolved a number of long-standing pain points with Kubernetes sidecars. And this sort of collaboration is part of our open commitment to open standard, or our commitment to open standards in the ecosystem and interoperability between Cloud Run and GKE. I'll now hand it back to Sagar to cover a customer success story with Cloud Run.
Thank you, Clayton. Those are a lot of use cases for one feature. Let's talk about a customer success story. Nasdaq is a Google Cloud customer who is committed to helping its customers efficiently monitor and report on their sustainability performance. In 2022, Nasdaq acquired Metrio, a platform that allows companies to report on their environmental, social, and governance performance. This platform collects, measures, and analyzes corporate sustainability data in real time and generates investor-grade reports designed to be shared strategically and cost-effectively with stakeholders such as ESG raters, rankers, frameworks, and regulators. Metrio follows a 4-step approach to report on ESG performance. First, it centralizes the qualitative and quantitative data. This data can come from various sources, including water consumption, waste disposal, HR, and electricity consumption. Then, create customized KPIs to measure this data, followed by generating investor-grade reports designed to be shared strategically and cost-effectively with stakeholders. And finally, publish that content online in an interactive way for consumption. Recently, Metrio migrated to Google Cloud from another cloud service provider. Let us see why. Metrio migrated to Google Cloud from previous stack that ran Ruby on Rails on a VM on a different cloud vendor. The old architecture was hard to scale because everything was co-located on the same machine. They were looking for a reliable new cloud provider that would allow scaling in a long run. They also suffered outages, which motivated migration to Google Cloud for its global coverage, scalability, security, and high availability. Metrio chose Cloud Run, Google's serverless compute platform, to fully power its sustainability reporting software. Cloud Run allows Metrio to run stateless containers that automatically scale up and down based on demand. This means that Metrio only pays for the resources that they consume when they are serving requests and do not have to worry about auto-scaling policies or managing infrastructure. As a team, Metrio wanted to operate with a focus on developer productivity to avoid the burden of managing operations whenever possible. Cloud Run is fully managed, so it removes the burden of patching Kubernetes versions and operating system versions, allowing customers to focus on delivering value more rapidly to their customers. Its ease of use and deployment speed also enabled Metrio to create new products as they migrated from their old infrastructure provider to Cloud Run. A few of Metrio's team members have a Kubernetes background and expressed interest in being able to leverage Kubernetes features on Cloud Run without having to manage nodes or clusters. Metrio has a startup mentality with ambitious deadlines and product visions. They really enjoy focusing on development rather than managing Kubernetes resources. Cloud Run made the ramp-up extremely easy and made the customer feel secure, knowing that if Cloud Run isn't a fit for a workload, they can easily shift to GKE and still have the services interpretable. Before Cloud Run, Metrio would release codes few times a month. Now, they can release multiple times a day, making it a lot easier to spin up sandbox and demo instances for fast product iteration. So what is Metrio's vision? Metrio's vision for cloud transformation was to separate databases from compute so that the storage performance and capacity can be scaled independently from compute. This database segregation also helps them achieve a SOC 2 certification. Metrio leverages Cloud Run as a compute layer and MongoDB for legacy data, while also leveraging Cloud SQL and AlloyDB for new services. Metrio uses 6 Cloud Run services per customer and have over 800 Cloud Run services running in production today. Metrio's data ingestion tool powers over 120 businesses, helping them keep their data clean and auditable with an edit history and activity log. They allow a wide range of data onboarding options, including templates, scripts, and APIs. This data can come from various sources, including water consumption, waste disposal, HR, and electricity consumption. As their application grew, the need to support download and upload of large files became the biggest blocker for Metrio's largest customers. Customers wanted the ability to upload large data files without refactoring their client or server code. Now I'll pass over to Clayton to explain how they accomplished this using Cloud Run and the Sidecars feature.
Thank you. So serverless platforms often have to impose limits on the size of requests to guarantee a high level of service. This comes, obviously, with a trade-off, is that you can scale faster and that responses are short-lived and often can quickly be resolved. In this case, Cloud Run's generous but not infinite 32 megabyte limit for the size of a request body created a choice for Metrio in how they were adapting their upload application for serverless. Should they update the serverless code, or should they update the server code, sorry, to accept HTTP2 connections, which have no limit on the size of request body, at the cost of additional development time and effort? Fortunately, for this talk, as well as for Metrio, the addition of multiple container support in Cloud Run opened up a simpler path. Metrio was able to use Envoy as a front proxy in the way of their existing server code to accept HTTP2 connections, convert the large HTTP2 requests into a large HTTP1 request. That happened locally inside of their Cloud Run instance and was then passed over the local network to the application. So there was no performance hit other than the latency involved in taking that bits. And the ability to leverage Envoy to do this versus putting this in their application code also meant that they were able to take a pretty common scenario that Envoy is tuned extremely well to. So this is another example of taking code that already works for a specific use case, such as handling network requests, and they were able to quickly integrate that into their Cloud Run instance once the Sidecar support was delivered. By deploying Envoy as a Sidecar container, they were able to avoid code refactoring and update the service. But they were also able to simplify the management of their microservices. And that use of Envoy was really key for them because their journey started with modernizing this application, but it didn't end there. With over 800 Cloud Run services, they increasingly anticipate, as we say for the long run, the ability to tie these applications together. Bringing Envoy in the near term as a front proxy also opened the door to allow them to bring their own service mesh and to define their own rules for connecting the front end and their initial upload applications on the database to more complex microservice scenarios that they anticipated having in the future. And overall, they saw improved deployment speeds, simplification of the management of the microservices, and greater scalability.
Thank you, Clayton. So what holds for future of Nasdaq's use of Cloud Run? In future, Metrio intends to leverage sidecars to secure communication between GKE workloads and Cloud Run, adhering to strict compliance standards of financial services. Metrio also plans to use OpenTelemetry collector sidecar to instrument their Cloud Run applications for custom telemetry for performance analysis, troubleshooting, and capacity planning. Use of OpenTelemetry will allow sending the tracing data to CloudTrace directly without any hops in between, thus optimally implementing the SLO and SLI support. Metrio's adoption of Cloud Run for its sustainability reporting software has resulted in numerous benefits, including improved deployment speed, simplified management of microservices, and greater scalability. The use of Cloud Run has enabled them to focus on delivering value to customers rather than managing infrastructure, reducing the time it takes to create new products. With its innovative roadmap, Cloud Run has become a game changer for customers like Metrio to meet their goals. Thank you.